300-pound metal star is hanging on 2 cables which are attached to the ceiling. The left-hand cable makes a 72-degree angle, so that's 72 degrees, while the right-hand cable makes a 19, and obviously this is not drawn to scale, but that'll be 19. So we want to find the tension in the cables. So I'm going to make a vector here and a vector here, and we want to know the length of this vector. We're going to call it T1, find its magnitude, that's for tension, and magnitude of T2 vector over here. And I'm going to make a vector that represents the weight of that star pulling down, and we know the length of that is 300. Often common to draw force diagrams with vectors in physics, and essentially if it's hanging there, it's not moving, it's in equilibrium, then the sum of all the forces equals 0. So if we added vector T1 plus vector T2 plus vector, we'll call it W for the weight, if we added those together, that would give us 0. So now let's go ahead and express each of those vectors. So vector T1 would be, we'll have it this one over here, and so we're going to put it in component form. So we don't know what its magnitude is. I'm just going to call it T1. I'm going to leave the magnitude brackets out just to simplify the notation. Then it's going to be cosine. Its angle is going to be around here, measured off from the horizontal. Well, there's a triangle here, so I can find this angle right here. That would be 180 minus 72 minus 19. That looks like that's 89. And then I have parallel lines cut by this transversal, so these alternate angles, this one would have to be 19 as well. So the angle for that vector is going to be the 89 plus the 19, or 108 degrees. And then the second components with the sine of 108 degrees. So let's go ahead and express T2, and that's going to be the magnitude of T2 cosine of, T2 is going to be this one right here. So we actually already have its angle. It's right there, 19 degrees. T2 sine of 19 degrees. All right, now let's go ahead and express W, the weight vector, and that's magnitude is 300, and it's going to be cosine of that angle all the way around to there is 270, and then 300 sine of 270. Let's go ahead and work the weight vector. Cosine of 270 is 0, so the first component 0, and sine of 270 is -1, so the second component is -300. So one of the things I could do is I could move the W over to the other side, and so T1 plus T2 would equal -W. And so the negative of W is 0 for the first component and 300 for the second one. So what I'm going to do is I'm going to add T1 and T2 together component-wise and put them equal to the negative of W's components. So let's do that. So T1 cosine 108 plus T2 cosine of 19, I'm adding first components, would need to equal 0. So let's solve this for T2. So T2 would be, moving that over, negative T1 cosine 108 divided by cosine of 19. Now let's do second components, and adding second components, T1 sine 108 plus T2, but instead of writing T2, I'm going to put it in terms of T1. So it's going to be minus T1 cosine 108 over cosine 19, that's the T2 part, and then sine 19 needs to equal this moved over, so 300. All right, let's go ahead then, and I'll move back over here where I've got space. We could factor out the T1, so we could solve it for T1, and we would have 300, and then we're going to divide by, if the T1 is factored out in front, it's going to leave us sine of 108 minus, and these guys I'm just going to write them as tangent, so it's going to be cosine of 108 tangent of 19. So if I work that out and put that in the calculator, that will tell me the magnitude of T1, or the tension on that first cable. So I can go ahead and get the calculator and put that in, and let's see, I get round to 3 decimal places. So the tension on cable 1 will be 283.699, and the units on that would be pounds, because we had our pounds here. All right, so there's our first answer, and then I find T2 by putting that answer in right here and taking the negative of it, multiplying it by cosine 108 and dividing that by cosine 19, and I get the tension on T2 is 92.719. And I should put, again, pounds.